Hello everyone. So today I will try to explain the Hill Cipher algorithm in cryptography and network security. So at first we need to take our letters as always from A to Z. Then we need a custom string length because this is a user defined code. So we need to define at first our text where the count will start from 0 and the initial value will increase and return the count for every part. Now we need to convert the lowercase letter to uppercase, where we need to define my upper variable name and it will show the result. And for character in text, the indexing will be start from 0 if find false, while the index in less than 26 it will show the characters in the index, and it will also give the result of the letters in this index. If found true, it will break and the number of index will increase by 1. If found equal false, it will also show the result as same and return the existing result. Then we need to remove spaces from the text and it will also show as a result. So we need to put a character in text. If the character is not equal the text, result will be plus or equal to the character and return a result. Then we need to define the character number. It will start from A0 and end with Z25. So we need to define the character to number where I is equal to 0 and put that in a condition while I is less than 26, letters will be equal to character and return the initial value. And if it is not happened, it will return -1. So now we need to convert the number to character because we need to define the text. So it will return in letters, and we also need to do to declare the modular inverse function. So here the defined function will be mod inverse. We can keep a variable as a and m. So a equal to a mod m, where the initial value x equal to 1. Now we need to put it in a loop or condition while x is less than m. If a into multiply by x mod of m equal 1, it will return the value of x and it will increase the value of x by 1, otherwise it will return none. So now we need to do the inverse of a 2 by 2 matrix, because in all those algorithms the matrix can be always 2 by 2, otherwise the matrix cannot be used. So here's the inverse matrix we need to define. So we need to declare the keys like A equal to 0 0, B equal to 0 1, C equal to 1 0, and D equal to 1 1. So now we need to get the determinant of this inverse matrix, where we know that A need to multiply by the value of D and it will subtract by B multiply by C, and then we need to mod it with 26. So the determinant of this inverse matrix can be equal to mod inverse of the determinant and 26. So if the determinant of inverse matrix is equal none, it will return the none value. Now in inverse matrix we can see that we have some conditions here. In every conditions we need to mod it with 26, so it will return the inverse value properly. Now we have the encryption part. In encryption we need to define encrypt text and key. So here's the text value, and here's the text which will remove the spaces between the text. So if the length of text mod 2 is not equal to 0, the text will be increased by 1, and see that it will x or not, it will return the cipher text. So I is equal to 0, it is the initial value. So now we put that in another condition. While I is less than the length of my text, it will show if p1 is character to number and p2 character to number, the text will increase its value 1. So in the cipher text part, we need to put the matrix value, which will be multiply with the plain text and will be add with the key, and then need to multiply with second part of the plain text and mod with 26. So cipher text will equal to number to character, and I will be increased by 2, and it will return the cipher text. In decryption part, we need to define decrypt, where it contains always as always text and key. So at first we need to inverse the matrix, then if the inverse is not equal to none value, it will return key matrix is not invertible. If that, now we need to put the value of the text and remove the spaces of the text, it will, so that it will return the plain text. So here the initial value is also 0. So now we need to put a condition while I is less than the text, it will, the cipher text will show the result part 1 and part 2, and it will also show the inverse of this matrix need to be multiplied by the ciphertext and then add to the other part with the part 2 of the ciphertext and then mod with 26. We will get the two part of this matrix of plain text. So it will show the plain text number to character part 1 and part 2, and the value of I will be increased by 2, and it will return the plain text. So in the main program, we need to print the Hill Cipher algorithm. We need to at first enter the key matrix. So here's the value we can put here in A, B, C and D. So the key will be like this: A, B and C, D. Then we need to put our choice if we want to encrypt it or decrypt it. So it will take out my choice, and it will show if the choice is encryption, the plain text will be take input and print the cipher text as a output. So if the choice is decryption, it will take the cipher text as an input and it will print the plain text as output. If there is no plain text and no cipher text, it will show the invalid choice. So that's all from the Hill Cipher algorithm. I hope that you all have understand this algorithm explanation. So that's all from today. Thank you very much for hearing.